So yesterday we learned about radical rules. Today we're going to learn about rational exponents. Now, once again, these rational exponents, this is actually on your formula chart. It's right here, rational exponent. Okay, so this is something we're going to actually take some notes on the parts of a radical and the parts of a rational exponent in your notes tomorrow, and we'll kind of put it all together. This is not a difficult concept, but it is going to help you out when you're actually solving problems. So first of all, when I put square root of 16, I get 4. Square root of 64 is 8. Square root of 81 is 9. If I were to put, instead of putting them as a, if I put this in, 16 to the 1/2 power, I also get 4. If I put 64 to the 1/2 power, I get 8. If I put 81 to the 1/2 power, what do you think is going to happen? That's right, I get 9. So raising something to the 1/2 power is the same thing as taking its square root. So what does that mean? Well, what that means is that the fraction, the parts of the fraction, so first of all, if I see a number and they ask me to raise it to a power, I'm going to raise that number. I'm going to use that power. So like, let's say I had like, let's not use that. Let's say that I had 144, actually there is a problem like this, and I'll see if I can find a squared, b squared, all raised to the 1/2 power. Okay? Well, I would say 144 to the 1/2 power, a to the 1/2 times 2, b to the 1/2 times 2. Well, I'd put 144, wait, no, I'm not doing that, I'm too lazy. I'd put 144 to the 1/2 power, and I would get 12. A to the 2 times 1/2 is just 1. B to the 2 times 1/2 is 1, and it simplifies like that, okay? So 1/2 is, we still, even if we see a half exponent, if we can, we try to distribute. So what does this mean? Okay, so what this means is, and we're going to kind of jump down here, and then we're going to do some examples. What this means is that when I look at one of these exponents, so if you look at this problem right here, what's my invisible exponent on square root of 16? My invisible exponent, my invisible root is 2. My invisible exponent is 1. And then I have 16 to the 1/2. So 1 is the exponent and 2 is the index. Again, square root of 64. This is a invisible 2 root and invisible 1 exponent. I raise it to the 1/2. So what that means down here is that m is my exponent and n is my index. Okay? So a to the m over n would be like a to the m, so the one on the top stays on the top, and the one on the bottom goes on the outside. You might also see a to the m, because they might put that on the outside, with the n as the index. So again, the one on the top stays your exponent, the bottom one becomes your index. So let's take a look and see if we can apply that to some of these problems, okay? So I'm going to write, if there's an invisible exponent, I'm going to write it down. The base, the radicand becomes the base of the exponent, and actually maybe we can write that down. Let's write down that a is the base, or the radicand. Okay, so the radicand becomes the base. Now, the exponent stays on the top, the index goes on the bottom. Okay, now can I put the square root of the 4 root of 32 in my calculator? Let me remind you how. You're going to hit math, and you're going to go down to 5 for the whatever root. I'm going to change that to the 4 root of 32, and I get that garbage, 2.378. Okay, now I'm going to try raising 32, I'm sorry, I'm so lazy, you guys, to the 1/4 power, and I get 2.3, I get the same thing. I'm not sure that's where they wanted me to write that, but that's what I did. Okay, so again, they're telling me here what this is, but square root of the 5 root of 240, goodness gracious, so the 5 root of 243, the 5 root of You know, maybe I should actually just do it the way I'm supposed to so I can remind you. So math 5, the 5 root of 243 is 3. If I were to write that as a fractional exponent, I would say 243 to the 1/5, which is what they have here. If I put 243 to the 1/5 in my calculator, I'm going to get the same answer. Now let's take a look at this one. Again, I wish we had left this off. Let's just not even look at that because I want you to know how to put how to create these. Okay. So again, what am I going to do if I see this question on STAR? I'm going to stick. So nope, I'm not going to do that. Nope, Maggie. I'm going to hit Math 5. Sorry about that. I'm going to hit Math 5. I'm going to put exactly what I see there. So I see the 3 root, the 3 root of parentheses negative 27 squared. And it gives me that. If I were writing this as a rational exponent, this, the radicand, would become my base. The exponent would stay the numerator. The index would become the denominator. So I could put negative 27 raised, nope, that's not it, negative 27 raised to the, what is that? What did we say? 2/3 power. Wait, what? Oh, what did I do wrong? Oh, that's not, none of that's right. I'm sorry, you guys. See, look, see, I catch myself. I'm sorry, I'm not, whatever. Now I get the same answer. What did I do wrong here, you guys? Because this isn't right. What's wrong with my answer that I got right here? What did I do wrong? Take a look at this and think about what I did wrong. Did this have parentheses around it when I put it in there? Did it have parentheses right here? If it has parentheses, it's got to have parentheses, okay? So I'm going to insert parentheses around that. Now I get the right answer. Again, substitution is so important. I'm so glad that I'm here to be a lesson to you about mistakes. Okay, let's try this last one. Okay, the 5 root of 64 to the whatever. Okay, so I'm going to do Math 5. Change that ANS to the 5 root of 64 raised to the 3rd power. I don't even know if I did that right. But look what it did. It put it inside the parentheses. Let's do it exactly like they have it written. So I have parentheses, I have parentheses, Math 5, the 5 root of 64, exit that and close the parentheses, all raised to the 3rd power. And it gives me, is that the same thing it gave me before? Okay, well look at that. Okay, now let's try it. Let's write it as a fractional exponent and see if we get the same thing. So my base, okay. So I have 64, and you see how right here it was the same way no matter whether they had the parentheses on the outside or the inside, to the 3/5, because my exponent becomes my numerator, my index becomes my denominator. Let's try it again. And do I have anything in parentheses? No. 64 to the, what is this, 3/5 power. I get the same exact thing, okay? So you're going to mostly see this in context of numbers, of letters, really. And I'll show you some STAR problems tomorrow, but come in with all of your questions, which I expect you're going to have them, because this looks weird, but it's not that hard, okay?